Hi, in this video, we are going to expand a term whereby the value of a is no longer 1. Let's look at how we do this by using the binomial theorem formula. So similar to our previous examples, we first write down the value of a. In this case, it is 2. The value of b will be negative x squared, and the value of n will actually be equals to 6. So we only need to expand the first 4 terms. And so the first term is now 2 to the power of 6, whereby a is 2 and is 6. And we have 6 choose 1. We have 2 here to the power of n minus 1. Now remember, n is 6, and we have 6 minus 1, which is 5. For b, we will have negative x squared to the power of 1. Now, once again, do note that the value of r and the last power here are actually the same value. And these two powers must always add up to 6. Okay, so let's write down the third term. 6 choose 2. And we have a is 2. B is negative x squared. And now I know that the last power will be the same as this number. These two power must add up to 6. So this must be 4. And that is an easy way to remember. Let's try again. So due to a lack of space, I will just write it at the next line. So we will have 6 choose 3 now. Let's write down the value of a. Let's write down the value of b. And the r value is the same as the last power here. These two powers must add up to 6. So this must be a 3. Now, due to the minus sign here, let us be a bit careful, all right, when we are doing our expansion here. So 2 power 6 is actually 64. We will have to multiply 6 choose 1 with 32 here and a negative here. All right, so this part will be negative because this is an odd power. Odd power, okay, a negative to an odd power will always be negative. All right, so this actually will becomes negative minus later. Okay, so 6 choose 1 multiplied by 32 is actually 192. And we will have an x squared. Now, a negative sign with an even power will become a positive. And we will have 6 choose 2 multiplied by 16 multiplied by x squared, which is x power 4. All right, so this will give us 240, and this will give us x power 4. So 240 x power 4. Now, here we realize that it will be a negative sign with an odd power, and we also remember that, you know, the signs will be alternating, right? So I will show you using the calculator how we get the last part here. So 6 choose 3 multiplied by 2 cubed, right? And this will give us a negative sign. So I have minus 160 and x is power 6. 1, 2, 3, 4. And we have fulfilled the first 4 terms. Remember to put the plus ... because we have not finished expanding every term in this expansion here. Now let's see how we can have a practical application of this binomial expansion here. So if we are able to form 1.99 to the power of 6, similar to the form here, we should be able to use the results from our previous answers to get 1.99 to the power of 6. So we observe that 1.99 is actually 2 minus 0.01. And so 1.99 power 6 will be 2 minus 0.01 to the power of 6. So what does this mean? It means that actually x squared is 0.01 and x is actually equals to the root of 0.01, which will give us 0.1. So we just need to substitute 0.1 into x, and input the value into the calculator. 64 minus 192 times 0.1 square plus 240 multiplied by 0.1 to the power of 4 minus 160 multiplied by 0.1 to the power of 6. And we have 62.1038. Now, try the next two parts here, which is similar to the previous two parts, and see whether you can get the solutions here. Next example here, you realize that sometimes the question actually writes in descending powers of x. All you need to do is simply expand it as per normal and double check that it is in descending powers. Now what happens if it's not in descending power? All you need to do is to swap these two values around. So you have minus 1 over x plus 2x squared to the power of 8. And the order will change. So later you realize that this is actually in descending order when you expand it. If you write it in this manner and you expand this, it will be the opposite, which is the ascending order. So let's try this first. Let's ignore this. We will only swap it if you realize that it is not in the right order as the questions stated. So as a habit again, write the value of A, write down the value of B, and write down the value of N. So we will now expand 2x squared minus 1 over x to the power of 8. So we will first have 2x squared to the power of 8. And we only need to do for the first 4 terms plus 8, choose 1. Write down A, write down B. The power is the same. And these two numbers add up to 8. So this must be a 7. Alright, so due to shortage of space, I'll write it below for the next term. Write down the value of A, write down the value of B. This R here will be the same as this power here. These two numbers add up to 8, so this must be a 6. Write down the value of A, write down the value of B, R, and R here. These two numbers will always add up to 8, so this must be a 5. So we have 1, 2, 3, 4 terms. And remember to put a plus dot dot dot. So if we expand this, we will get 256 x to the power of 16. There's a minus sign here and an odd power. So you know that the next term must be a minus. Okay. So we'll have 1024 x to the power of, here will be x power 14 over x. So x power 13. Okay, I will show you in detail the next term here. So we will press 8, choose 2, multiply by 2 power 6. And there's no more other constant values. So we get 1792. All right. So here will be power 12 over power 2. So the x is actually power 10. So let's try again. Again, you realize that this is actually negative of a odd power, so we should have a minus sign later. Just write this first in case we forget. So we have 8 choose 3 multiplied by 2 power 5, which is actually 32. And there are no more other constant that we need to multiply. And so this will be our coefficient, 1792. And using the law of indices, let's find the x power, which is 10 here, over x cubed. So we are left with power 7. And remember to put the dot dot dot. Realize that it's already in descending order and in descending powers. So we do not need to swap this around. If we swap, it will actually be in ascending power. Alright. So why don't you try the next question here and see if you can get the answers. Yeah. In this last example in the video, we will expand this term here in ascending powers up to x cubed term only. And later we'll see how we can use that to find the constant term when we have a multiplication with an additional term here. So let us do the first thing, which is to expand this up to x cubed. So what we need to do is, first we will need to write down the value of a. And since there are 3 terms here, let these other 2 terms be b. And the value of n will be 8. So let's expand 1 plus 2x plus x squared power 8. And that will give us first, without referring to the binomial expansion formula or the binomial theorem formula, let's us see whether can we do this using from our memory. So first I will have 1 power 8 plus 8 choose 1. I'll write down the value of a. Okay, I'll write down the value of b. And I know that the r and this power is the same. These two add up to 8, so this must be 7. Likewise, you can also totally ignore the ones. Okay, I'm doing it this way just to recap the formula for binomial theorem better. Next, I will have 8 choose 2. Then I write down a, I will write down b, r and r. These two add up to 8. So I need up to x cubed, so I need to do it one more time, and I'll explain why again later. So 8 choose 3, write down the value of a and the value of b, and I will have the same values, r and r here. Since they add up to 8, this must be a 5. Remember to put the dot dot dots. Now you realize that if I expand it, this will be a cube. And anything after that will be more than cube. So that's why we still need to include one last term here. Simplifying this, we will get 1 plus, here we will first note 8 choose 1 is actually 8. 8 choose 2 is actually 28. And 8 choose 3 is actually 56. Okay. Alright, so that is easier later when we expand it. So 8 times 2, we will have 16x. And we'll have 8 times x squared, we will have 8x squared. 28. Now you can expand this here. Alright. So what you can do is you can have a side working if you want to. So we will have 2x plus x squared squared. Okay, let's do a side working. That will give us 4x squared plus 2x cubed plus 2x cubed. So it will be 4x cubed. And then we have x power 4. Okay, let's use this. So we have 28 multiplied by the first term here, which is 28 times 4. So we have 112x squared. 28 multiplied by the second term here will be 112x cubed. 28 multiplied by this term here, no need, right? Because we only want the term up to x cubed. So you don't have to write it down. Finally, we have 56 multiplied by, no, it's not 2. So this is 56 multiplied by 8x cubed. All right, again, 56 multiplied by 8x cubed. So we will have 448 x cubed. So simplifying all the terms, we have 1 plus 16x plus 120x squared plus 112 plus 448, we will get 560 x cubed plus ... Now, since we already finished expanding it, we need to multiply by this term here to find the constant. So one easy way is just simply to expand it. So to expand this, we will have, okay, let me once again write in red, 3 minus 1 over 2x squared, which is 3 minus 1 over 2 multiplied by 3 minus 1 over 2. Okay, and we will have 9 minus 3 over x. Then here we will have plus 1 over 4x squared. So which of these terms in red multiplied by which of these terms will give us constant? Okay, so when I multiply these two, it will be a constant, right? So I will have 9 multiplied by 1. Right? And if I multiply this term with this term, I should get a constant as well. So negative 3 multiplied by 16. If I multiply this term with this term, I will get a constant. So 1 over 4 multiplied by 120. So choose the terms after multiplying together will give you constants. And we will have 9 plus negative 3 times 16 plus 1 over 4 times 120, which is actually 30. So we'll get negative 9. Now, why don't you try the next example, the very last example for this video, and see if you can get the answers here. That's all for this video.